So we're 2 minutes in. Let's go ahead and get started. So for those of you who are real into safe harbor considerations, go ahead and pause your view now, screenshot, get that permanent record that you want of our safe harbor notifications around, the contract implied by information being received. I'm not going to comment on it because obviously I'm not a lawyer, so take of it what you will, but there's our safe harbor notifications. This is Data Nerd Days Part 2, and we're talking observability for microservices. Again, if you do have any questions, go ahead and drop them in the chat. If you do interact in the chat at all, I will personally get you some swag. This is not a new Relic offer. This is a Noshnika fee offer because I appreciate it. I appreciate y'all interacting. Look for my email address up there or my Twitter. Come find me on Twitter or email me with where I should send some swag. And the code word is spaghetti. So my name is Noshnika. Nika is fine if you have trouble pronouncing Noshnika. As a guidepost, the hashek here in Noshnika is pronounced like the CH in chocolate. Just a are my DMs not open, Tim Walter? You know what? I'm not going to solve that injustice right here on this during this stream, but I will absolutely put in a reminder on my phone here to actually do that, to open my DMs. I apologize for that. Serverless_mom, send me a DM. I will open my DMs right after this session. Okay. So we're talking about observability for microservices. And so that's really, we got this sort of short agenda here. It's going to end up with, thank you so much, Gautam, thank you so much. I apologize. I fear I'll mispronounce your first name, so I will not try on stream. As you imagine, as someone named Noshnika, I have heard many people's attempts to pronounce a first name correctly and don't always appreciate it. Oh my gosh, we've got great attendance here. I absolutely love that. Thank you so much, everybody, for coming out. So the general agenda here, we're going to define observability, which, you think we all know, but we'll just do a quick check-in on that one. We'll talk about how microservice architecture grows in complexity and how understanding large and complex systems is difficult. We'll do a quick demo of stepping through some serverless stuff within the New Relic interface and how we can try to get some insight into the structure of a particular interaction and get some insight into how our architecture is structured. Okay. So let's talk about what is observability, and let's use an example. We usually always use this example where, it's 2 a.m. and we've got a spooky report from somewhere where we're all concerned about. And while that's great, I think that, also observability is often starts at a point like this, right? Some users report that they can't check out when they use a coupon code. Now, this is sort of a perfect example for observability because it kind of hits all the points that makes us the most nervous. So it's not, the whole system is down at 2 o'clock in the morning, which really might be, network maintenance or some other things that maybe aren't super closely connected with really needing high definition observability. Maybe the whole site is down, right? We could just go and test the site ourselves. We could use our cell phones. We could go take a look at it. But when someone's saying, hey, not everyone experiences a problem, it requires certain inputs to get that problem to repeat itself. And the problem is critical, right? Because if we run an e-commerce business and someone is saying, hey, we cannot check out, right? That's a big concern. That's a big concern. So this is a pretty classic observability problem where we're going to say, God, if we can improve our observability a bit, we're going to be in better shape. Okay. So a lot of the time we talk about observability like it's this thing that we can add in. And that's very much an issue sort of what if you're not, into the New Relic ecosystem or another observability tool, you get people sort of looking to say, well, just I want to add observability. So what's a tool that adds observability? And that is usually not that right. When we look back at this problem, we don't necessarily think that we can just say, hey, I can just add a single tool and that will go ahead and resolve it. So observability, much like security, is a design goal, right? And observability is, right, the time to understanding, right? It's the time between saying we know we have a problem, which, hopefully observability is part of the solution for detecting it. But occasionally, right, we get messaged by something. For my time doing my very start in the tech industry was doing tech support. And very often that support line really was the first way that you knew you had a problem. You might not necessarily you might not necessarily take that first report seriously or know that it was a widespread problem. But yeah, you might not get it from a monitoring tool that you first report you have a problem. But once you have a problem, observability is the time that you get to understanding that problem and knowing how to fix it. So my classic example is that if you see that you start having slower and slower responses and you just restart your server, then you actually have like zero observability, right? Like you sort of know how to solve the problem in a very, brute force way, but you really don't have the ability to understand what the problem is or what's actually causing it, right? Classically, it might be that you're leaking memory somewhere, but so you don't know where that is. And so your observability relatively is quite low. When we survey, especially people who work in serverless and containerized applications, when we ask what are the primary problems that you face, very often observability comes over to others that we might kind of think as being more important, right? Problems of observability come before complexity and before cost as sort of key job concerns, right? We all worry about being that person who runs up a $10,000 AWS bill overnight. You have to go talk to your account rep and try to get it sorted out. And certainly, with a cloud architecture, this is going to be a big focus of this talk. We have this issue with increasing complexity. But observability comes above those in most people's list of key concerns. Okay. Right? When we pursue an error, our modern systems have fewer things that can go wrong on each component, but far more components. So this is kind of my attempt to sort of simplify this. I previously had used the term node instead of component here, but I thought maybe that got a little bit confusing. People start thinking you're talking about a Kubernetes node necessarily. But really what I just mean is that there's an increased number of points on the stack. Now, things like physical incursion and most of the internal networking things when we're using a public cloud provider, we're not usually worried about, right? We know that these things are probably handled correctly. They're not left to the concern of the user. But we do have more of those points to troubleshoot. And that's significant, right? It's not small to say that we do have to have a little bit of concern about where we are seeing problems. And this gets us to one of the harsh truths about using a cloud application and using a microservice architecture. Monolithic systems were easier to monitor. And now it's true that monolithic systems could have a lot more going wrong, right? You could have the bare metal layer and the OS layer could be the things that were causing you problems in ways that, certainly a serverless platform really can't. And even most virtual machines, right? We expect that certain things about those lower layers are going to be handled automatically for us. But the fact is that there was kind of one place to go to look for answers, to understand those systems. And so that means that monolithic systems were, frankly, easier to get your arms around and get a good sense of than some of our modern systems. So let's talk about the things we might want to know to be able to understand this question of, again, we have this mystery error, right? We generate a 500 error when we put in a certain coupon code. Now, it's likely, right, that we're not seeing that on the front, that's not being caused by a front-end error, but, let's take a look through this, right? We'd want to see the error rates on each component, right? So if we are only getting errors out of our React app, right, that's the only place where we're generating and reporting errors up the stack, and we're not seeing any errors from our application layer or from our database layer, that maybe that is suggestive. Maybe somebody's putting in a coupon code that we wrote some regex within our front end that it can't parse correctly or something else, right? Then we want to look at throughput on the back end. So this is really critical. Right after maybe I should have put these 1, 2, 3, 4, but these are kind of things you can check simultaneously. But you would want to look at throughput on the we want to look at throughput on the back end, because throughput on the back end is it's one thing to say, oh well, good news, there's no errors being seen by the application layer, by the database layer, and so that can leave you really hunting through your front end code to say, oh my gosh, there must be something on the front end that's not handling this correctly. But you would be given pause if you stopped and said, well, wait a minute, how many requests are actually getting through to the back end? And this is kind of critical. How does that compare to previous time periods, right? The same time yesterday, the same time a year ago, what's the average throughput? If the throughput has suddenly dropped, then you really probably aren't looking at a front-end issue, and you probably are dealing with something that is blocking that communication, whatever that error might be. And then do another step on that to say, okay, how many requests are actually getting through to your database or other data store? And if that is way down, then sure, you're not going to see many errors on that data store. Everything might look great, but that is going to indicate that we have a problem. And we're going to take a look at the anomaly view in just a minute. Actually, you know what? I'm going to see if I can open that anomaly view now to give kind of a sense for that. I'll have to change over my screen share here. So just one moment while I do that. And let me just get that open and get the anomaly view open. Okay. So when we use something like this, okay, that's a little bit cumbersome to switch over, so I won't do it a bunch of times during this talk. But when we use something like our lookout view, right, this is a really critical piece. Right now, we don't have a ton going on in this particular setups lookout view. We'll have a ton of stuff to look at in lookout, but I just want to take a quick look at this. When we have our lookout view, we get a sense of both, is some behavior currently anonymous, and what is the scale of that anomalous, maybe I said anonymous, but what is the scale of that anomalous behavior, right? So right now we have some increased response time on a few of these services, and but this scaling here gives you a sense of like, okay, well, those services, what do they represent as a total part of the stack? And also, do they have increased or, and this is really critical, decreased throughput? And that decreased throughput is really going to be an important piece, because that decreased throughput could indicate, that we have a connection problem further up the line. Okay, as I'm switching over, feel free to drop in any questions that you have to the chat. And again, anybody who chats with me, go ahead and get me in touch with me. Drop me an email, and I will get you some swag, because I really appreciate y'all coming out to Data Nerd Days. We've got Gautam, we've got Walter, we've got Brendan, Tim, and Theodore. I owe all of them swag. I'm going to go broke sending out new Relic coffee cups, but I don't even care, because I'm glad to have y'all here. Okay, so back to the presentation. So next, we want to look at changes to permissions and configuration and deployment history. Now, those aren't really going to be covered by this presentation, but I think they're worth discussing, because it really is critical to look into something like a tooling that is going to allow you to go back and audit just a bit what exactly happened in the past. Now, if you're using something like AWS, right, there are inbuilt tools for the AWS side of this, but I just think it's an ongoing concern. It's something that's worth considering. What are these what are the changes to the application code, and what changes have happened to your infrastructure configuration? Okay. So there are 3 elements in general to a well-measured system, and I didn't make separate slides for these, so I'm just going to go through these. They are generally metrics, logs, and tracing. And these can help each other out, they can connect with each other, but very often when we think of observability, we usually think of one of these 3 pillars. So we think of either metrics, we say, oh yeah, observability meaning, how fast is my performance? how many errors am I generating, that's observability, right? Or we think of logging, right? We say, well, I'm doing observability means I'm doing a ton of logging. Now, I like to think of this as a 3-pillar thing because, and this is not my analogy, by the way. This is I know I've seen it in CNCF stuff from a couple of years ago, so this is not my analogy initially. But when we talk about logging, right? Logging is a very key piece of observability in general. When we think of observability as the time to understanding, our observability might not be great even if our logging is very good, because the time it takes to sort through really complete thorough logs might be extremely high. So that means that, yes, logging is part of the observability solution, but cannot on its own really be a complete solution. And anything that sort of pretends to be is actually probably at least doing metrics off of logging and hopefully doing tracing. Tracing is the third pillar, and it is just as key, and especially in a microservice architecture, tracing is really key. And let me see if I put in this slide next. No, I didn't do this. So tracing in most contexts now has become not just direct tracing through an application, but distributed tracing. So sort of, first we had these traces that showed sort of every point that a request had been through within an application's code. And our next step, both for New Relic and across the industry, was to connect the front-end request or the mobile app request to that path through the application code, maybe including a little bit of like, it hit the database here or what have you. But distributed tracing, which is not just a New Relic idea, also exists within OpenTelemetry and other places, and is demonstrated in AWS X-Ray and other public cloud solutions. Distributed tracing says, let's see where this request to all of the microservices within a system. So let's talk about what the practices are that can get us there, the strategic decisions that are most key, right? So let's start with tools consideration. So, you're at your New Relic TradeConf. So, of course, we're going to talk about New Relic a little bit, but also there's some other tool pieces outside of your observability tool that are really key to this decision, right? Tom McLaughlin, we came up with we had a discussion question during I believe it was a DevOps Party Games or some other event, and made this joke about, like, which tool should you use for infrastructure as code? And the answer is yes. That we talked about having some insight into what permissions and infrastructure changes had happened across the stack. And it's really just important to use some kind of tool. So what's out there, right? There's things like Pulumi, Opta, Stackery. It was out. Stackery recently joined with AWS. There's the AWS CDK, and these are all tools to say you're going to have some kind of code or template file somewhere that's going to define how your infrastructure is configured, rather than going in and making direct edits to a console, or obviously making bare metal edits where you're like accessing a virtual machine via CLI. So infrastructure as code is a key part of the solution. It's obviously not a part of your observability tool, but it really makes a huge difference to observability as you're trying to deconstruct an error. Oh, I did have the slide about tracing. It's become distributed tracing. I had moved it a little bit from where I expected it to be. So this is one piece of the screenshot of a distributed trace. And let's go ahead and look over at an actual distributed trace now. So give me one moment to do that. So I apologize if the gears grind just a little bit while I'm changing windows here. So close the screen share, reopen the screen share. Rotate. There we go. Okay. So looking at distributed tracing for a serverless function within New Relic, when we get the grouping of tracing here, right? So here's our summary view of this demo application, which has a pretty simplistic actual application code, right? We have a data store operation, which is storing something in DynamoDB, and then a lot of our time is taken up in web time. So it doesn't seem like we're doing very much of the application layer. So that means distributed tracing is going to be a big part of our solution when we say, hey, why is this taking so long? Well, the first thing we notice is, right now, the requests are not taking terribly long at the Lambda level, right? We have very, very low duration for most of our requests. So we want to take a look at distributed tracing to give us a sense of, okay, when we're getting these requests, how long are they actually taking? So when we click through to that grouping of traces, and then we click into look at a single one of these, this is purchase confirmation, so this really matters. We get a few pieces here that are really key. So one of the things that we get, you'll notice this sort of purple bar here, is how much of the time is being taken up with a Ruby service sort of before it hits our Lambda at all. And this is because distributed tracing is able to stitch together the spans of time that happen on other New Relic monitored components within our stack. We'll go ahead and drop in the chat if you have questions about this or how this is implemented. But this is something that you get out of the box when installing the New Relic serverless agent. So it's not something that you have to do special config to do. So this is really key because it shows us, okay, a big chunk of the time that we're looking at is taken up within this Ruby service. So we can click through here and go and take a look at that. But then the other piece is that we can also look at the trace for our actual service and see, okay, what exactly, 35 milliseconds is not really a ton of time for this Lambda to be taking up, but we can see how much of that is taken up in a particular request. And sure enough, almost all the time associated with this Lambda is taken up in this put item request. Now, another tooling component, so key, this beautiful graphic that we're looking at here for our distributed trace, is going to give us a sense of what other components were touched with this request. And one of the key things here, and I emphasized this on an episode of the Nerdlog recently, if you follow the Nerdlog, do check it out. We talk about this in depth, is that this is a map of not a complete service map, right? This is not every component that exists within this application. These are just the components that were touched for this request. And you can also see a map for anomalies that says, hey, for a certain anomaly pattern, these are the other components that are touched, or for a single entity saying, hey, when this entity, and I believe we can click through to that here. Let's see if we can get there. So when we look over at summary, I believe we can load this up. Okay. Looks like I'd have to do that for an APM value, so that's no problem. We'll just take a look at this trace closely. So one of the things about this is that scoping your maps really, really matters for a microservice architecture. When we want to say that we want to look at what's connected, a map of absolutely everything that's calling everything else is probably not going to be the most useful view. With this, because we're able to see the number of calls that pass between and the number of calls that we've seen as those spans, it's a really critical piece because it gives us a sense of, okay, what's actually involved with the sort of problem that we're currently exploring. Now, we can from here also get a sense of what is the status of those entities, right? In this case, we're not in the middle of any kind of outage, so most of these do look green, but they allow us to take a look at, hey, how many hosts are actually running this? What is the status of each of those hosts? And even what are their dependencies? What do they rely on for support? Okay, hopping back to the presentation here. Okay. So another really significant tools-based comparison. If you're a New Relic diehard, you're going to be like, look, this is not New Relic here. This is a Grafana dashboard, actually. But it actually shows one of the values that is key to New Relic, and if anyone else can replicate, especially if you can replicate it in an open source way, more power to you, is that remember that the speed with which we can read a dashboard has a direct effect on observability. Now, on this little preview, you're not able to probably read these data labels, but that's not really what matters, because what matters about this, and you're going to see this on New Relic dashboards as well, is that the ability to look at this and kind of get a sense of what might be going on is pretty high, right? We can see that whatever this yellow line is here, it's probably not closely related to this crisis. We can see we do have some kind of outage, right? We even have maybe a drop off of something. And we can sort of sync up in time visually where we think something might have started and what might be affected or related to this issue. And so that speed with which we can read and understand a dashboard or view or any kind of data view is a really critical part of the explanation with an observability tool. Will this functionality also work for non-serverless services? If I have a bunch of microservices running on ECS Fargate and they're all instrumented by New Relic, would New Relic automatically create the service map showing us the connected services for each transaction? Great question, Arpan. And again, if you want to get in touch with me at, looks like my DMs may be closed on Twitter, so feel free to hit me up at nv@newrelic.com. Please do come get some swag. But this is a great question about distributed tracing. So yes, this functionality does work for non-serverless services that are instrumented with New Relic. So in this little example here, right, this trace, I guess, is actually mainly covering external services. I won't do the screen share switching over, but that Ruby service that we were looking at was not serverless Ruby. That was just serverless running on a virtual machine someplace that was also instrumented with New Relic. So yeah, that is a key piece of this that we are that we care about, which is, oh, thank you so much for posting that over, that we care about is that this is going to be, distributed tracing is going to cover more than just other serverless functions, because that's the nature of the beast, right? We're not necessarily going to run everything serverlessly. So we need to be able to connect things happening on virtual machines, things happening in other hosted clusters somewhere, or even on our bare metal somewhere within our own stack to our serverless functions. Yeah, so we're going to pass headers through, which will be connected, including with application performance monitoring, the sort of traditional non-serverless compute stuff. Great question. Okay, let's talk about stuff you can do without tools. This, by the way, there's a image credit here, but this is an example of an Earthworks that was created without any metal tools. So structure is quite helpful. So when we have some regularity of structure, we're able to chop things up a lot more effectively. And so this is my intro to thinking about structured logging. So, New Relic's logging tools and connections to get logs along with your metrics and other data. And you can see that on the distributed trace we were looking at. There's a link to logs there. That's fantastic. But actually, outside of adding any kind of log reporting or log viewing or log querying tool, structured logging is incredibly helpful. So this may or may not be readable in your view, but the concept is just that we're going to use this structured logging to include references to objects, to other objects within the stack, and in a way that we can parse later down the road. We're not just trying to do a raw text parse with regex or what have you. And so structured logging is a really powerful way to encode more data than you kind of think you're going to need. And one of the things I really love about the structured logging best practice is that it's not an all or nothing operation. I mean, I think in general, right, adopting infrastructure as code is going to be something where you're going to have to define the spike and take some time to add, to switch over to infrastructure as code fairly completely. Structured logging is something you can do in fits and starts, right? You can create like a state object that you're passing around, and or an info object that you're passing around, and say, okay, now instead of just logging out a separate line about whatever's going on, I'm going to add an attribute to that state object and update that instead. And if I want to check in, I'll just go ahead and log that whole state object instead of just a single piece. There's now natively supported structured logging within Kubernetes. I think it's 119 has that support. Don't quote me on that one. I do not have that in my presentation notes. But you can also include object references here. And so it's a really powerful tool. It's really going to add to the value with which you can do these pieces. And then the last thing is people to add to your observability practice. And I think this is generally the one that does not get quite the amount of time that it should when we're thinking about observability concerns. The sharing of knowledge and data across your team and the sharing of expertise is a really key part of any observability practice. And that can be surprising, right? Isn't observability just how quickly you can understand the problem? But remember, different people looking at the same dashboard will understand it at different speeds. So the ability with which you can have knowledge sharing sessions and analysis and clear postmortems of sort of what previous incidents were, including, and I would really emphasize this is an important piece to include, when we go over a particular problem, try to go over what did we use to understand the problem, including, being very honest with ourselves. Hey, because our internal network has its own caching, we always end up using a mobile device to try and check the site from outside. We always end up doing this. These are the steps that we go through to really successfully analyze the problem. Okay. So that is most of the content that I wanted to cover for this session. So I wanted to open it up to questions from y'all. If you do have any, we're getting up on time. Can you search by log properties? Like all the events where app name is equal to a console application exe. Dan Smith, great question. Sorry, I missed it in the chat. I didn't get the little notification. But the answer is yes, you can. I am not the logs specialist within New Relic, but yes, the whole point of the logs tool is that you can do various queries to it. Obviously, structured logging helps because it means it'll be a little bit easier to do those kinds of queries because you'll be expecting what format it's going to appear in. But yes, you can do log queries with New Relic. That's a really good question. And Dan, get in touch and get some swag. I may, in the background, possibly go open DMs on Twitter right now so people can find me at serverless_mom. But also, please do go ahead and here's my little sort of wrap up message. But do of course do set up with New Relic if you're just checking it out. Do use try New Relic, and also do check us out on every week when I do a little session about the state of New Relic and the state of the observability industry called the Nerd Log. You can watch us on Twitch at twitch.tv/new_relic. You can find me on Twitter at, sorry for the typing noise, serverless_mom. And yeah, I'm going to open my DMs right now while I wait to see if we have any follow-up questions. Okay.